Hello, my name is Andy Shek-Yu-Chung. I'm thrilled to share our research on locational marginal price and its significance in the spot market. LP indicates the marginal cost of electricity at a specific grid location, factoring in generations, import, demand, export, and network constraints. Ideally, LMP is calculated with minimal total system cost, considering transmission, load, loss, and operational constraints. LMP consists of three things. First is the system energy price, second is the cost of marginal loss, and the third is the transmission construction cost. From the table, it shows the LMP of G1 at full capacity and half capacity. Bus 1 have the lowest cost and the bus 14 have the highest cost. Also, the total cost of G1 in full capacity is lower than the total cost of G1 in half capacity. This graph shows the LMP at different buses of these two scenarios. The increased total cost or in the half capacity generator 1 scenario can be attributed to the reduction of generator 1's Pmax by half, necessitating other generators to produce more power to meet the low demand. Since the cost associated with other generators is higher than the generator 1, the total cost consequently rises. In part 2, bus 1 had a power generation of 194.33 megawatts, while part 3 shows that bus 1 generates only 166.2 megawatts, resulting in a difference of 28.13 megawatts that must be produced by other generators or buses. In this system, the cost of generator 1 is lower than that of generator 2, 3, 6, and 8. Therefore, when generator 1 operates at half load, other generators are required to produce more power and leading to an increased total system cost. Generators located at different locations will tend to supply power to the nearest load when generator 1 is operating under a half load condition. This explains why the power generations of generators 2, 3, 6, and 8 also increase when generator 1 is at half load, further contributing to the overall system cost variations.
Hello, my name is Dave Tan Siu Chung, and here comes my part in question 2. In this question, we're going to look on the marginal cost of transmission losses, which we'll be able to learn the impact of concretion on LMP. In question 2, the first part, we have been told to disable the branch 2, which is the link between bus 1 and bus 5, which show a red cross on the image. As a result, we can see the total costs have rise up to 8,260.4 per hours, which has a 12.12 megawatt difference, higher than the previous simulation. The LMP rise except for bus 1 and 2 and 3, which is because the power generator by generator 1 must flow through branch 1 when branch 2 was disabled. The generator 1 reserved more power delivered to bus 1, 2, and 3, but no power is delivered to the remaining bus. In the question 2, the second part, we have been told to disable the branch 2 thrust, the branch 1 limited to 100 MVA. As a result, we have put a graph of change of LMP as shown in the PowerPoint. Firstly, the total cost of this case is higher than the basic model. The generator of bus 1 is cheaper than other bus which disabling branch 2 have a concretion in bus 1. And this limits the power flow from bus 1 to bus 2, and therefore the generator 1 reduces generation. And this reduced capacity shall be taken off by other generators with higher costs, and then as a result, the total cost in this case is increased.
Greetings, my name is Susan. Today, I'd like to talk about LMP in different models. We analyze the system using the optimal power flow function and compare the two models. Our findings indicate that the discrepancy between the two models is minor, approximately 1%. However, the power loss in the linear model is relatively larger, about 37%. In other words, that leads to economic losses. The piecewise linear model offers simplicity and ease of interpretation, while the polynomial model's optimal powerful calculation is more complex, leading to longer computation times. Despite these differences, both models can provide valuable insights into the behavior of LMP under various conditions. In conclusion, a study of the EE524 system has demonstrated LMP is influenced by factors such as total system cost, transmission losses, and operational constraints, including transmission congestion. Our findings contribute to a deeper understanding of the LMP under constraints effect. This is the end of my presentation. Thank you.